In this video, let's work on the remaining problems in the bicycle problem. The first question asks, what is the utilization for station 4? What is the utilization for station 4? The formula for the utilization is just flow rate divided by capacity. So to find the utilization of station 4, we need the capacity of station 4. What is flow rate? Flow rate is the minimum of process capacity or the demand. In our problem, there is no mention of the demand, so we assume the demand is infinite. That's why flow rate is equal to the process capacity, which we just calculated to be 60 units per hour, or 1 units per minute, or 1 by 60 units per second. Remember, process capacity is the capacity of the bottleneck. You can express in any unit you want, but to calculate the utilization, we have to make sure the flow rate and the capacity of the station, the capacity of this station for which utilization you are calculating, they are in the same unit. You have to make sure these are in same units. Let's do all three variations. First, let's calculate this utilization using units per hour. So using units per hour, we want to find out what is the flow rate, and we want to find out what is the capacity of station 4. Let's go back. Using units per hour, the capacity of the station 4 is 80 units per hour, and the flow rate, which is same as the process capacity, which is same as the capacity of the bottleneck, is 60 units per hour. So using units per hour, the flow rate is 60 and the capacity of the station 4 is 80, which is same as 75%. Now using units per minute, we should get the same answer. Let's see if we do or not. We want to find out what is the capacity of the station 4 and what is the processing capacity or the flow rate of the process in units per minute. Let's go back again. The capacity of the station 4 expressed in units per minute is this 1.33, whereas the flow rate or the processing capacity or the capacity of the bottleneck is 1. So we have 1 divided by 1.333, which is again approximately 75%. If you put in the calculator, you might get a slightly different number. That is because of the rounding error. Using units per second, again, we want to find out the flow rate in terms of units per second and the capacity of the station 4 in units per second. Capacity of the station 4 units per second is 1 by 45, and the capacity of the process or the process capacity or the capacity of the bottleneck expressed as unit per second is 1 by 60. So we have the flow rate is 1 by 60 and the capacity of the station 4 is 1 by 45. This calculation is a little bit more involved. 1 by 60 multiplied by 45 divided by 60. Just to divide a fraction by another fraction, we switch we reverse the denominator and the numerator of the lower fraction. So here, this is 45 divided by 1, 45 divided by 60, and this is also 75%. So using any of those capacities and the combination of flow rates in any unit, we should get the same value. The thing to note is utilization itself does not have any unit. It is expressed in terms of percentage, 75%, 75% and 75%. This would make sense. What this is saying is station 4 is 75% utilized. It had the capacity of producing 80 units per hour, but it only has to produce 60 units per hour. But another way to say, it has the capacity of producing 1.33 units per hour, but it only has to produce 1 units per hour. Another way to put it is it has the capacity of producing 1.45 units per second, but it only has to produce 1.60 units per second. Now, in this question, there is a verb-is without ignoring the production of the first and last units. This is a very normal verb-is to say, don't worry about the scenario when we're still trying to fill the pipeline of the process. This is like ignore the times when all the processing units don't have an item to work on yet. Okay. So the fourth problem asks us, what is the average labor utilization of the workers, ignoring the production of the first and last units? Again, the same verb as we see it. The formula for average labor utilization is labor content divided by labor content plus the idle time. So if we look at the labor content in each unit, there is 225 seconds. We get this number by adding this 50 seconds, 60 seconds, 30 seconds, 45 seconds and 40 seconds, which is equal to 225 seconds. At the bottom we have the labor content 225 plus the idle time. To get the idle time, so out of the 60 seconds, this guy works only 50 seconds, that is, he stays idle 10 seconds. This guy stays idle for 0 seconds. This guy stays idle for 30 seconds. This guy stays idle for 15 seconds. This guy stays idle for 20 seconds. So if we add 10 plus 0 plus 30 plus 15 plus 20, we get 75 seconds. So the idle time is 75 seconds. Thus, we have 225 divided by 300, which is same as 75%. Thus, the average labor utilization is 75%. The fifth question is, assume each worker is paid $15 per hour. What is the cost of direct labor for the bicycle? So if the formula for direct labor content is total wages per hour per unit of time, and the flow rate per hour. Flow rate per hour. So we have 5 workers and we pay them $15 each, and we want to find out what's the flow rate per hour, which we have already calculated. The flow rate per hour is the process capacity expressed in terms of units per hour, which is again same as the capacity of the bottleneck. So we produce 60 units per hour. Thus, the cost of the direct labor content is 15 multiplied by 5, which is $75, and the flow rate per hour is 60. So the direct labor content is $1.25 per unit. Now the question is, why did we use, for the flow rate, why did we use this value, the 60, and not this value, which is units per minute? The reason is we were given the wage rate in terms of dollars per hour. As our numerator was expressed in terms of dollar per hour, we needed the value of flow rate in terms of per hour, which is 60. Thus, we get the value 1.25 units per hour.